All right. Hello and welcome everyone. So, welcome back to this amazing platform of Tutee Learning. We are live right now. I hope I'm audible to all of you. All right. So, welcome back to this amazing platform. And also, as of the last class, we started with discussing about the vectors algebra, right? So, in our previous discussion, we finished up discussing about the basics of vectors, right? And what was the necessity to basically develop the vectors, right? And along with that, we also learnt about some more terminologies in vectors, right? So, this was what we did in our previous class, right? I hope you have understood the previous session. And if you're new to this particular platform and you haven't watched the previous session, I would request all of you to please go back and check out the playlist on vectors. Okay, so in if you check out the channel and in the live tab, you will find out all the lectures that has been taken so far in the previous topics of mathematics. Okay, so if you are following us for a long time, you must have been knowing that we have already covered the entire portion of calculus for a long period of time, and especially for the JEE Mains and Advanced syllabus, right? So we are trying to help you out with the preparation for JEE Mains and Advanced for the upcoming year 2026. So with this, we have been starting with vectors in 3D, right? So this is our lecture number 2 for vectors algebra, and today we are going to start discussing about another important portion on vector algebra, that is basically the addition of vectors, right? So from today, let us start discussing about the addition of vectors. All right. I hope you are ready to start with this particular lecture. All right. So please let me know in the live chat. Are you ready to start with the lecture? Okay. So, all right. So I hope I'm audible and you're all ready to start with the vectors addition, right? All right. So before we start with discussing about the vector addition, let's now quickly discuss about one of our important thing that is called as position vector, right? So as of the last class, we have discussed something called about the types of vectors, right? So types of vectors, once we analyze the types of vectors, I can say position vector is another type of vector, right? Or let us try to understand the rectangular resolution of vector. All right. So let us try to understand the rectangular resolution of vectors. All right. So let us try to understand the rectangular resolutions of vectors. All right. So what do we actually mean, or what does this particular thing refer to when I say about or talk about the rectangular resolution of vectors? Now I'm going to talk about in terms of 2D as well as in terms of 3D. Okay. So we are going to discuss about 2D and 3D rectangular resolution of vectors. Okay. So as of the last class, what did we understand? That any vector can be simply given by a line segment joining the initial point to the final point, and the direction of the vector is denoted by the arrow which is going from the initial to the final position, right? So this is what we have learned, initial to the final position, as of the last class, right? So a vector, the direction is given from the initial to the final position, right? And we write this kind of vector as a b vector, right? I hope this is clear, right? Now what I'm trying to say, let us try to understand what is basically meant by the position vector. Okay, what is basically meant by position vector? Okay, so what is basically meant by position vector, let's try to understand, right? Now think of this Cartesian coordinate. Now think of the Cartesian coordinate. Now let me first go with the 2D thing, then we will discuss about the 3D thing, right? So if I take up the Cartesian coordinate, so if I take up the Cartesian coordinate over here with the x and the y axis, now let us say I take up any point P on the Cartesian coordinate which is given by the ordered pair x comma y, right? Now this particular point P is a position on the Cartesian coordinate which is represented by the ordered pair x comma y, right? Now, now once you understand this particular point as an ordered pair, now if I join this particular line from the origin to get to the position, then this is called the position, right? Now, if I join it from the origin to this particular point and I represent that by a vector, then this particular vector is nothing, or it is is known as position vector. Okay, so the position vector is basically a vector which is joining the origin to that particular point on the Cartesian coordinate, right? So on the Cartesian coordinate, if I join the point or and the origin by taking origin as the initial point and the point as the final position, then the vector that I'm going to obtain, that particular vector is therefore known as the position vector, right? So this is the basic definition of position vector. All right. Now, similarly, in case of 3D, in case of 3 dimension, if I have the 3D coordinate systems over here, any point on the coordinate plane is given by the this particular thing x comma y comma z, and again over here, if I join it by the origin and this particular vector, this particular OP vector is the position vector. I hope this is clear to all of you, right? Now, now let us try to understand how do we write or how do we form a vector, right? Now, for understanding that particular things, we have to quickly understand about the addition of vectors, right? All right. So now, if I talk about briefly in terms, let us say generally we write the position vector as R, right? So this R. Now, generally, when I talk about the rectangular resolution of vectors in 2D or 3D, then what I'm going to do over here is that, now please try to understand. I will give you the proof for this, or I will tell you how it is coming up. It is generally given as x times of I cap, y times of j cap plus z times, sorry, in the 2D it will be only till j cap, right? So this is what is known as the rectangular resolution of a vector in 2D coordinate, right? And similarly over here, if I represent the OP vector as R vector, the R vector over here will be given as xi cap plus yj cap plus zk cap, where I cap, j cap and k cap are the respective unit vector along the x, y and z axis representative. Okay, so respectively, and therefore let us try to understand how we get to this particular expression, but this is basic known as the rectangular resolution of a vector, right? I hope this particular thing is clear, right? So therefore, now along with this, there is certain more things to understand, that is basically that how to represent the vector in terms of the, so this is basically representing the vector in terms of the rectangular coordinates, right? The x and y axis, right? However, there are certain more things that we also need to understand with respect to the orientation from the x, y and z axis, right? Now, if you look it carefully over here, now I will try to draw a better diagram to represent this particular scenario. So let us say, let me try to draw the 3D axis or 3D coordinate system. Let's say this is the x, this is the y, and this is our z axis. This is our z axis over here. Right, now let me try to draw a cuboid over here. Let me try to draw a cuboid over here. All right, so now let us say this particular point of the cuboid is given as point P. Let us say this is the point x comma y comma z. Right, now over here this is the origin. Now if I join this particular point with this origin, I'm going to get the position vector, right? I'm going to get the position vector, right? Now, and this is basically what I'm denoting it as R vector. So R vector denotes the position vector OP, right? Generally, vectors are denoted by a small letters. Okay. So this is denoting the vector R, and that is basically the position vector, right? Now, if you look into this carefully, if you see over here that this vector R makes certain angle with the respective x, y and z axis. So if I talk about this particular angle which the vector makes with the x axis, let us say is alpha. Similarly, the angle which the vector makes with the y axis be beta, and the angle which the vector makes with the z axis be alpha, right? So if I'm telling that this particular are the angles which these vectors are making with the corresponding x, y and z axis, then interestingly there are certain more things to understand, is that these are nothing but also called as the direction cosines, okay, or direction ratios, right? So then we come across two more things also known as the direction cosines or direction ratio, right? So if I take the cos alpha, cos beta, and cos gamma, these are nothing but are known as the directional cosines. These are nothing but the directional cosines. So direction cosines are nothing but they help to represent the angle along the respective x, y, and z axis. Okay, so cos alpha, cos beta, and cos gamma are therefore the direction cosines. Okay, right? So these are known as the direction cosines, right? Now, and also I can represent them as L, M, and N. Generally, they are basically written by this particular nomenclature L, M, and N, which are basically nothing but the direction cosines, okay, or the cosines of the angle that the vectors makes with the positive x, y, z axis respectively. All right, so these are known as the direction cosine, right? Now, if I talk about in this 3D space only, in this 3D coordinate system only, if I talk about how should I calculate this direction cosines alpha with cos alpha, cos beta, and cos gamma. So for that, I'm going to use simply trigonometry over here, right? So if I say now, let us see how we can find out cos alpha, and in a similar manner, we can definitely find out cos beta, cos gamma, respectively, right? So let us see how we can do that. Now, if you look at this particular vector over here, right, this particular vector, and this is my x-axis over here, and this is what the angle that the vector is making with the x-axis or the positive x-axis, right? So this is, I'm calling it as alpha, right? So in order to find that, what I'm going to do is that, let us say that this particular vector is a unit vector. So if I try to take this particular vector as an unit vector, so I'm transforming this particular vector as an unit vector, okay? So please try to note that first of all, I'm going to transform that particular vector into a unit vector, and then I'm going to drop a perpendicular, and then I'm going to drop a perpendicular, right? So after I make this as a unit vector, I'm going to drop this perpendicular over here, and in this case, once I'm dropping this perpendicular, all right, so then, and even if you don't even consider this as a unit vector, then also the difficulty is not there. But however, direction ratios are defined for a unit vector, right? Whereas direction ratios are defined for any vector, right? So please try to understand this particular thing in careful and be bit careful on this particular thing. All right. So all right. So once I know this thing, or even if you don't take the unit vector, I know. Let us see how we can find alpha over here, right? So if this is a right angle triangle over here, my cos alpha will be given by this particular distance, that is a base. This particular distance, that is a base, upon the perpendicular hypotenuse, right, which is basically the mod of the r vector, right? Now now how will I find this particular base? That is, if you notice, this base is nothing but the projection of this particular vector on the x-axis, right? So if I need to find out what is the projection or what is the length of projection on the x-axis, what I need to do, I just simply need to say that this particular thing is nothing but can be resolved by taking a dot product, can be taken a dot product with the I cap, can be taken by taking a dot product with the I cap, right? And then divided by the modulus of this r vector. Now, how we are getting this particular relation, I will try to explain you in bit detail. And now, from physics, you must have heard about or studied about the dot product, which can be defined as mod of x dot y, x vector dot y vector can be given as mod of x vector mod of y vector into cosine of theta. That is, theta is the angle between the vector, right? Now, if you haven't studied about this, don't worry. We'll definitely going to discuss about this in our upcoming lectures when we're going to discuss about the multiplication of vectors, right? So now, from a physics, if you recall, this x vector dot y vector is given like this. Now, if you think of what do you mean by projection, right? What is meant by projection? So, if I have this as vector A and this is my vector B, now if I want to project this particular vector onto vector B, let us say the angle is theta, then if I draw a perpendicular distance over here, this particular length can be given as the projection of A onto B, right? And which can be simply given in terms of trigonometry, it can be given as mod of A times cosine of theta, right? So if you recall over here, now if you take the dot product over here, so if you try to take the dot product over here, then A dot B is going to be equals to mod of A mod of b into cosine of theta. Right. Now I want only mod of a cosine theta, mod of a cosine theta, which I can also write it in terms as a dot b divided by b vector, mod, right? Which is basically going to give me mod of a vector cosine theta, which is nothing but the projection, right? So this is basically also known as the projection formula, which I'm going to discuss about in our upcoming lecture as well, right? But this is basically how do we find projection, right? Similarly, over here, when I'm trying to find the projection of this r vector onto the x-axis, I'm simply going to take the mod dot product with this x-axis vector, or the unit vector of which represent the x-axis, and then divide by the mod of I cap, which is going to be 1. So this will denote the base. This will denote the base of this particular right angle triangle, and the r vector, this magnitude r vector denotes the this hypotenuse, right? Which is basically going to be cosine of alpha. So from here, my cosine of alpha is equal to x upon. So from here, I'm going to get cosine of alpha as x upon x square plus y square plus z square. I hope this is clear, right? Please let me know if this part is clear or not. Please let me know this part is clear. Is this part clear to all of you? Odex, hi Himanshu, is this part clear to you? Is this part clear? Please let me know in the live chat. Is this part clear or not? Is this part clear? All right. So I hope this part is clear to all of you. Now, in the similar manner, or likewise, we can also try to find out the value of cosine beta and cosine gamma, right? So we can also try to find out the value of cosine beta as y upon square root of x square plus y square plus z square, right? And also along with that, we can find cosine of gamma. We can find cosine of gamma as z upon square root of x square plus y square plus z square, right? I hope you can follow this, right? I hope you can follow all these things, right? So we will get the following relation as follows over here, right? So cos alpha, cos beta, and cos gamma is obtained from that particular rectangular resolution of vectors, right? All right, Vedant. All right, great Vedant. Okay, now once I have this relation, what you can observe, and a careful observation you can see is that if we try to take cos square alpha into cosine square beta in plus cosine square gamma, if you just add up all the square of these cosines of the angles, if you just add up all the square of the cosines of the angle, what you are going to get is interesting, is basically, so if you try to take up, all right, so if you try to take up this particular sum, you're going to get something like this. All right, so when you solve it, you are going to definitely get equal to 1. So what you can see is that the summation of cosine square of alpha, where alpha, beta, gamma are interchangeably used over here, then cosine square alpha is equals to 1. So summation of all the cos of, or the summation of the square of the direction cosines is obviously going to be equals to 1. So if I know that the direction cosines are alpha, beta, if they are basically given as L, M, and N, so then I get right over here that L square, M square plus N square is equals to 1. All right. So then I'm going to have L square, M square plus N square is equals to 1. I hope this is clear to all of you. So this is one of the very fundamental problem that can be asked in your JEE Mains, right? So based on this, they might ask you certain more questions. All right. I hope this is clear to all of you. I hope this thing is clear to all of you, right? So from here also, you can also directly find out that what are we going to be the direction ratios, direction cosines, right? So for a given vector, if I need to find the direction cosines, you will see that these are nothing but these are the components, these are the x, y, or the I cap, j cap, and k cap components of the unit vector. right? These are just simply the unit vector component of that particular vector, right? So if I give you an example to basically find out the direction cosines, so let us say I give you an example that find the direction cosines of this particular vector 3 cap 3 cap minus 4 cap minus 5 cap. So please try to find out the direction cosines of this particular vector, right? Please try to solve this. Please try to solve, okay, let us say this plus over here. Okay, please try to solve this particular problem. Please try to solve this problem. Please try to solve this problem. Please try to solve this problem. All right. So please try to solve this problem so that I can discuss about the solution. And you will be seeing that the interesting part over here is that the direction cosines will come out to be the components, I, J, K components of the unit vector of itself. Okay. So if you try to find out this unit vector, the unit vector of this particular vector, and then you represent the individual component, those are the components which represent the direction cosines. Okay. Or even if you don't understand that, you can just simply use this particular formula over here. Okay, so cos alpha, cos beta and cos gamma are given by this formula. So please try to use that and let me know the direction cosines. Please try to solve that. Please try to solve that. Okay, so try to solve this problem. Alright, so once you solve this problem, try to find out cos alpha. You will see cos alpha will come out as 3 upon square root of 50. Similarly, cos beta will come out as minus 4 upon square root of 50, and cos gamma will also come out as 5 upon square root of 50, right? So if you carefully observe these components of the direction cosines, you will see interestingly is that now square root 50 can also be written as 5 root 2, right? 5 root 2. All right. Now, if you observe this carefully, and if you again also if you consider this as a r vector, and you try to find out the unit vector for this r vector, what you are going to get? So if you try to find out the unit vector of this r vector, you are definitely going to divide it by the magnitude of this particular vector, right? So if you divide by the magnitude, that is square root 50, then the individual I, J, K components are nothing but they are the direction cosines. All right. So this is the basic understanding about direction cosines. I hope this is clear to all of you. So please note this particular thing so that whenever we are going to use the idea of direction cosines and direction ratio, definitely in the discussion of 3D geometry, this particular thing is going to play a very important role. Okay, but since it was relevant along with the basics of the vector, so that's why I discuss it in a bit basic details. Okay, but the other things that will be definitely discussed that about in our next topic, that is going to be 3D geometry. Okay, so once we finish our vectors for the vector algebra portion, then we're going to start with 3D geometry. In the 3D geometry part, we're definitely going to discuss about all these small aspects. Okay, so let's now discuss about the properties of vectors. That is, firstly, we will try to discuss about the addition of vectors. Okay, so let's discuss about addition of vectors. Okay, or what do we actually mean when we try to add two vectors? Okay, what do we actually mean when we try to add two vectors? All right, so addition of vectors. All right, so let's try to understand what is the addition of vectors and what is a law or the rule regarding the addition of vector. So we are going to start with discussing about the triangular law, the triangle law, or the, I should write triangle law of vector addition. Okay, so let's try to discuss upon the triangle law of vector addition. Let's try to discuss about the triangle law of vector addition. So if I talk about the triangle law of vector addition, let us say, to understand this triangle law of vector addition, let us say two vectors are there, right? So if I have these two vectors and I make them two vectors such that now all the vectors that we're going to discuss in our topic of mathematics are going to be free vectors. So I can move them freely anywhere and I can put them in any position, right? However, the orientation must remain the same, the direction must remain the same, the magnitude must remain the same, right? So we are not changing the vector. We are just freely rotating it. We are freely moving it anywhere in the free space. Okay. So let us say that I try to take these two vectors such that the head. Now, if you recall in our basics of vectors, this is something which is we called as the head of the vector, and this is something which we called as the tail of the vector, right? So if I make the vectors come together such that that head of the first vector is coinciding with the tail of the second vector. So if I'm trying to form this vector arrangement such that the head of the first vector is coinciding with the tail of the second vector. Hi sir, I was about to be given a mentorship session but no response from your side. Uh Inzamma, I actually contacted you, okay? I contacted you for the mentorship session, okay, and you didn't respond to it, okay. So please try to respond to that particular thing as well. So initially, when you contacted us, I was not available, but the next time when I tried to contact you, you was not available. So I don't know what's like going on. All right. So maybe if possible, please try to contact us again so that we can again get back to you. Okay. Sir, it is possible to clear JEE mains of mains April if I start. Yes, it is definitely possible to clear JEE mains. Okay, it is definitely possible to clear JEE Mains. It doesn't matter you come from any institute. It doesn't matter you come from NEET institute. Okay, any institute, anywhere you come from, if you prepare it carefully, consistently with the given momentum for the examination, you can definitely clear it. Okay, and please subscribe to the channel and also hit the bell icon so that whenever we are live, you get the notification. Okay, and please study this particular thing carefully. Okay, sir, I will drop a message then. Yeah, sure. You can drop message. Yeah. Now, so once you are clear with this particular arrangement of these vectors, now if I join the tail of the first vector with the head of the second vector, tail of the first vector with the head of the second vector, in this case, if you look over here, then this particular vector which I'm generated by joining the tail of the first vector with the head of the second vector is nothing but it is called as the vector addition or the addition of A vectors and B vectors. Okay. All right. So I hope this is clear. All right, I hope this is clear. So this is how we talk about vector addition, right? Now, along with understanding this triangle of vector addition, we also need to understand certain more things to basically get on over the basic thing, right? So the basic thing over here is that the first vector, the head of the first vector should coincide with the tail of the second vector, and then once you have that particular arrangement, when you join the vector starting from the tail of the first vector to the head of the second vector, that particular vector becomes your A vector plus B vector. I hope this is clear, right? So this is the basic understanding that you need to have in order to understand the triangle of vector addition. Now, along with the triangle of vector addition, there is one more law that you need to understand, which is another, again, an extension of this triangle law, is also known as the parallelogram law. Okay, is the parallelogram law of vector addition. Okay, it's known as the parallelogram law of vector addition. Okay, so let's try to understand what does this parallelogram law of vector addition refer to. Right, so it actually refers to that if I have two vectors and I take these two vectors as the sides of the parallelogram, as the two sides of the parallelogram, okay, and then if I complete the parallelogram such that I take the other two sides as parallel to the, like this way. So I'm completing the parallelogram over here like this, right? So in this case, if I call this as vector A and this is my vector B, then the diagonal vector, then one of the diagonal of this parallelogram is going to represent what is known as the A vector plus b vector. Okay, a vector plus b vector. Alright, so this is the parallelogram law of vector addition. So where you understand that if two vectors represent the adjacent sides or two adjacent sides of my parallelogram, then the sum of the vectors is basically represented by the diagonal of the parallelogram whose initial point is given as the point of intersection of the two vectors. Alright, and this is known as the parallelogram law of vector addition. Right. Now, how does it come about? It's very simple. We can see that since in parallelogram, this particular side and this particular side are parallel, and by the concept of equal vectors, right? Let's try to also understand about what is the equal vector, which we have already discussed in our basics class, right? So, equal vector means if I have two vectors whose magnitude and direction are the same, then they are basically called as equal vectors, right? So, over here, this B vector, and let me name this parallelogram as A, B, C, and D. So in this case, my AD vector and BC vector is going to be the same. So this is also be B vector, right? Now if I apply ABC in the triangle ABC, if I apply the triangle law of vector addition, A vector plus B vector is definitely going to give me the A plus B vector, which is basically nothing but the AC vector, right? So this is basically denoting the diagonal of the parallelogram. All right. Now, in the same manner, if I just change the direction, so in the triangle law of vector addition, if I just do slight modification such that I just change the direction of addition, okay, I just change the direction of the b vector over here. Now if I join this vector like this way, in this case, I'm going to get a vector minus of b vector, right? Alright, so also what you can understand from this particular drawing is that what I'm going to write over here is that a vector plus b vector is basically given as, so let me also write the point as ABC triangle. So that is given as AC vector, right? Or what is the AC vector, right? Now, if I represent this AC vector as C vector over here, what I can see is that if I just change the direction of this AC vector by saying that it is CA vector, in this case, my A vector plus B vector, and if I just change the, so minus of C vector or this is equal to 0 vector. Right. So what I'm doing over here is that if I take this AC vector in the left hand side and I write the algebraic equation, I can write the thing as A vector plus B vector minus C vector equals 0, because C vector or is denoted as the AC vector, right? C vector is denoted as the AC vector. Now, if I just again relate to this equation over here, what I can do is that I can write the same equation as A vector plus B vector plus CA vector, and that I can equal to 0 vector, right? So then what I can see is that now if I try to denote, let me write, do not write C vector over here, let me only write in terms of AC vector. So what I'm going to see is that if in a triangle, if I take up all the vectors in the same direction, if I just take all the vectors in the same direction and I add them, so let us say this is my A vector, this is my B vector, and this is my C vector. And if I take all the vectors in the same direction such that it forms a closed loop, then the sum of all these three vectors in a closed loop is definitely going to be equals to 0 vector. Okay, so this is one of the most important key results, that when I take all the vectors in the same direction such that they form a closed loop, then I'm going to get the result as the 0 vector. Okay, so I'm going to get the result as C vector. All right, I hope this part is clear to all of you. All right, so based on this particular understanding, we can extend our laws of addition to another law that is also known as the polygon law of vector addition. So what you can understand is that if I take multiple vectors and I just keep on adding them such that it forms a loop, then the final resultant is going to be equal to 0 vector, right? So only thing that I need to observe is that even if I take up multiple vectors, okay, even if I take up multiple vectors like this, such that they form a closed loop, then the sum of all these vectors, so let us say A vector, B vector, C vector, D vector, E vector, and F vector over here, such that they form a closed loop, then the summation of all these vectors is going to be equal to 0. But what I can understand is that now if I just replace this direction of this F vector such that this is my arrangement of all the 5 vectors, and if I just join the tail of the first vector with the head of the last vector, and if I just join this, then this particular thing is going to represent nothing but that is the sum of all the vectors. Okay, so this is basically also known as the polygon law of vector addition. So if I have multiple vectors and I leave one vector such that I join the tail of the first vector to the head of the last vector that is basically there, and that is going to denote the summation of all the n number of vectors. Okay, so this is basically the basic understanding about vector addition and vector subtraction. Okay, so in our today's class we learnt about vector addition, laws of vector addition, and vector subtraction, that is nothing but the adding a vector in the opposite direction. Okay, so I hope this particular thing is clear to all of you. So once this is clear, then if you note over here this parallelogram, and if you try to plot the another diagonal like this way, let us say I'm interested into the db vector, so then db vector becomes equals to, so dv vector becomes equals to a vector minus b vector. Okay, so our dv vector becomes equals to a vector minus b vector. Okay, so the two diagonals represent, one of the diagonal represent the addition of the vector and the other diagonal represent the subtraction of the vector. Okay, so please take a note of this particular understanding. Okay, so this first vector, this particular diagonal denotes, so this diagonal denotes the addition of vector and this particular diagonal denotes the subtraction of the vector. All right, so with this particular understanding we are now ready to understand about the algebra or the properties of vector algebra, right? And then we can go about to solve lot of questions in our upcoming lecture. So I hope this particular class is clear to all of you, and with this we come to the end of today's lecture. So where we discussed about the vector addition and direction cosines, right? So in our upcoming lecture, we're going to discuss about the properties of vector addition, vector subtraction, and then we're going to solve some question regarding that, right? And also we're going to solve some question regarding the coplanar of vectors and collinearity of vectors as well in this particular lectures. All right, so please do subscribe to the channel and hit the bell icon so that whenever we are live, you get the live notification and you can attend the lecture at the comfort of your home. And if you're interested about taking in live online batches, you can always contact us on this particular number. So if you have any queries, any questions, you can always contact us on this particular number that is given on the screen, 850-92-797-63. Okay, so please feel free to contact us or WhatsApp us on this particular number to get access to one-on-one online batches. Okay, so one-on-one online batches is basically already we have started for JEE as well as for NEET examination. So you can always contact us for this particular classes. Okay, so please contact us on this particular number so as to get access to our live batches. Okay, and where you can also get a mentorship sessions. Along with the mentorship session, you can also get access to our doubt clearing as well as one-on-one batches. Okay, so one-on-one batches is a much better batch in terms that you basically get to study one-on-one from me, and also you can cover and clear all your doubts. All right, so with this we come to the end, and thank you for your lovely attention, and I hope to see you in our next class.